All right, so we're going to cover Le Chatelier's principle and equilibrium. So first of all, we have to understand that most of the chemical reactions we've been looking at, we've been talking about how they go in a particular direction, right? So you have reactants and then you get products. But oftentimes with solutions and even gases, what happens is when you dissolve something, it kind of goes back and forth between products and reactants. And so what happens is we have what we call forward and reverse reactions. So for example, if I took solid sodium chloride and I dissolved it in water, they would break up into or dissociate into sodium ions and chlorine ions, and these would be aqueous. They would be dissolved in water. What happens is not all of it fully dissolves. In fact, some of it stays in solid form. So what happens is you actually have a forward reaction. So the forward reaction here I'll put in red, going this way. So you have sodium chloride dissolving into, but you actually have the reverse reaction occurring too, where once dissolved, some of them kind of revert back to the solid form. So you actually have and so instead of writing both of them back, what we do is instead of writing both reactions, we just do this, showing it's both ways. In fact, we kind of write like this. Okay. All right. So what happens is eventually you reach equilibrium, and so this is a video of a reaction of the opener that you did. But in this case, we have the forward and reverse reaction occurring at the same rate. So they reach all of these reactions reach an equilibrium where both the forward and reverse reactions are occurring at the same rate. Okay, so the equilibrium, you kind of think like everything's in balance. All right. Now, if we disrupted the balance or the equilibrium, what would happen? Well, a guy named Le Chatelier kind of said that if there's a stress applied to an equilibrium, the system shifts the direction to relieve that stress. And so there's different ways to talk about that stress, or the three stressors we can talk about. But basically, just think like it always wants to get back to equilibrium. So if you think like if Le Chatelier's principles, it always wants to relieve the stress, or you think it wants to get back to balance. So how could it get back to balance? I sometimes think of a seesaw. So like if, for example, this is my product and my reactants, right? So here's my reactants, here's my products. And if one side becomes too heavy, right? So let's just say there's a stress, and so now there's too many products. Well, then the reverse reaction will pick up so that there'll be more reactants produced. So eventually they'll go back to reactants and products, right? Okay? And so the reverse reactions, like too many products, okay, we got to go back the other way, all right? Let's use an example. So there's three types. The three types are concentration. So you can change the concentration of the reactants or products. You can change the temperature, and then you can change the volume, or when you change the volume, right, that changes pressure. Okay, so let's go over each one. So concentration. So let's just use our example. Oops. So they're in equilibrium. Na plus aqueous. And then Cl minus aqueous. Okay. So let's just say I increased, like I added. Well, let's just do it this way. So, number one, added more NaCl. So if I added more NaCl, that would cause more reactants, right? Like that would So if you think about this, the seesaw, right? I'm adding more reactants, so it would tip. So it would be like this, right? But remember, these are in equilibrium, so it's like, I need more. So which way would you think, what do you need more of to make it kind of back to equilibrium? We need more products, don't you? So there's more reactants, so you need more products to kind of even it out, so to speak. And so which way will the reaction go? The reaction will go where you can produce more products. So the reaction will go this way. Why? Because the reaction wants to produce more products because there are too many reactants. And so the reaction would shift to the right. So that it would favor the products, right? And the other way, if we added, let's say we added sodium ion, right? The opposite would occur, where now there's too much of the reactant, so now we got to go shift back this way, and it would go to the left. What about if I removed sodium chloride? Well, if I remove sodium chloride, that means where is there less? Well, there's less sodium chloride, which means there's less reactants, right? So then now there's more products than reactants, so we need more sodium chloride, so it would go to the left. Okay? All right. And so you can kind of see, like, if you remove stuff or take stuff or add stuff, it kind of goes, it will kind of want to overcome the deficit or where there's less, and so it'll move in the direction where there's less stuff, so to speak, or lower concentration. Okay, temperature is another one. So before we start with temperature, we got to talk about a couple things. One being exo and endothermic reactions. So an exothermic reaction means energy is released, right? And so an exothermic reaction, so if we dissolve copper 2 chloride, so copper 2 chloride is exothermic. It gets really hot when you dissolve. So what happens is, if energy is released or exothermic, that means the heat is being released. And so, whoops, I'm supposed to make this an equilibrium, right? So it would go this way. But exothermic means it's being released, so it's a product. Remember what it produces, so this is a product. So you would have heat on this side. If it's endothermic, an example would be the dissolving of ammonium chloride. In this case, and look, I didn't balance these, but this is endothermic. It's really cold, so it takes heat in. And remember, reactants are what it's taking in, so heat would be on this side. Okay? All right. And so if you treat heat as like one of the products reactants, it kind of makes sense. So what I mean by that is, let's just say we take CuCl2 and okay, so if I increase the temperature, which way do you think the reaction would go? If I decrease the temp, which way would it go? So if I increase the temperature, that means I'm adding more to the product side, right? Because heat's one of the products. So which way would it go? It would want to counterbalance it and go to the left. If I take away heat, that means this side's getting less, right? And so it would want to go to the right. All right? And then lastly is volume and pressure. So let's do that. Let's use the same. Let's use that same example. Sorry, I keep on messing the equilibrium up. All right, so that's your reaction, right? And yeah, there's going to be heat here, right? But anyways, what we look at with volume and pressure is So pressure is related to the number of particles, right? Volume is kind of related to the number of moles. So if we look here on this side, how many moles do I have? Well, I have 1 mole. And then on this side, though, I have 1 here, and then I have 2 here, so I have 3 moles on this side. I'm just looking at the coefficients. And so if I decrease the volume here, now if I decrease the volume, that means there's less space, right? So if I decrease the volume, there's less space. Well, the equilibrium knows that. It's like, oh no, there's less space. Now, if there's less space, that means you can fit only a lower amount of moles, right? And so, which way do you think it's going to go? Well, it's since the equilibrium realizes like, oh, I can only fit here. I'll produce 1 mole, whereas here I'll produce 3 moles. They would want the reaction to go back to the left. So in some ways, it wants to relieve pressure, because if you decrease the volume, you're increasing the pressure, right? Well, if you're increasing the pressure, the equilibrium realizes I can't have this many moles or this number of particles. I'm going to go left, or I'm going to go towards you. It wants to go towards the area with lower number of particles, because remember, the lower number of particles also relieves pressure, right? And so, as the pressure increases, the equilibrium works to decrease the pressure. Right? It's kind of like opposites almost. And so if it increased the volume, what happens to the pressure? Well, the pressure is going to go up. Or sorry, if you increase the volume, the pressure goes down, right? So there's more space. Well, if there's more space, that means I'm lowering the pressure, and so it's going to go in the opposite direction. It wants to keep everything the same. So it's like, oh, pressure's going down. I better make sure the pressure goes up. I'm going to go towards where there's more moles. I'm going to produce more moles, if that makes sense. Okay. My suggestion, though, is that make sure you work on this as well.